Let's take a 2-minute break, and then we'll actually get into how inter-domain routing works. Okay, let's actually design inter-domain routing now. So a quick recap of our setup here is we have a graph. Nodes in the graph are ASs. Destinations are IP prefixes, and links represent both physical links and business relationships. And we've talked about what kinds of paths we like. There's kind of routing follows money kind of paths and so on. Let's talk about how we actually implement that. Right? And so when we think of how we're going to design inter-domain routing, we've learned already, we have these two canonical approaches to routing that we've discussed, right? Link state and distance vector. If you had to choose one as your starting point, it's not going to solve all the problems we need. But if you had to pick a starting point, which would you pick? And why? Yep. Yeah, exactly. We would pick distance vector, and the reason is we don't like link state because link state offers no privacy. You have to broadcast your neighbor information to the entire graph. Right? And we said ASs don't want to reveal their business relationships. Even worse, it offers no autonomy. The only way link state works is because we all agreed on what metric we're optimizing. For that, I have to reveal my policies to everyone so that they can say, oh, this is how this AS would pick paths. Otherwise, link state doesn't work. So distance vector is a more attractive starting point. Right? The problem is it wasn't designed to implement policy. It was also doing least cost routing. The hook that we're going to exploit in distance vector to make it do what we want is the fact that distance vector is working by advertising per destination costs or per destination path selection. Right? And so that's going to be our hook. It'll make it clearer in a minute, but it's going to be our hook because it's going to allow us to say, on a per destination basis, I'm going to hear advertisements from other ASs, and on a per destination basis, I'm going to implement some kind of policy in which routes I pick. And I do it locally, I don't have to reveal it to everyone. That sounded big. We'll get to how that makes sense in a bit. So BGP extends distance vector in order to accommodate policy. The way we're going to talk about how BGP works, because BGP gets very detailed very quickly, so instead we're going to talk about going from distance vector to BGP at kind of an approach level and how policy is implemented. And then next lecture, we're actually going to get into the details of BGP messages and so on. But at this point, we're still in the general approach. So the basic idea behind BGP, if you remember distance vector, what was the basic idea? I tell all my neighbors about my least cost path to every destination. Right? So for each destination, I say, this is my least cost path. And then I listen to what my neighbors tell me, and I pick the best route to every destination based on what I hear. And we iterate between those two. We're going to do the same exactly for BGP. So in BGP, we're going to say that an AS, so now a node is an AS, advertises its best route to a prefix. We call this export. This is BGP terminology for advertising. So an AS will export its best routes to all its neighboring ASs. And at the same time, each AS is going to listen to all the advertisements it received, and it's going to select what it thinks is the best route for each advertised prefix. And we're going to go back and forth between those two. This should sound very familiar to you. This is what distance vector did. The change is that policy is going to be implemented in terms of which routes you advertise and which routes you select. Okay? So when we say BGP is inspired by distance vector, there are three similarities really. One is that we're doing these per destination advertisements. Destinations for BGP are prefixes. The second, there's no global sharing of network topology information. Instead, what we have is this iterative distributed convergence process. At no point am I telling everyone, these are my neighbors, these are my policies. That said, we're going to have to change distance vector, and there are four crucial differences. I think we've kind of touched on most, if not all of them, but let's repeat them so we make sure we're clear. The first is that BGP may aggregate destinations. So if you remember in distance vector, you got an advertisement that said, for this destination, here's my least cost. At no point did I mess with that destination, right? I just took that destination and I updated my least cost path and then I advertised it back out. I didn't tamper with what that destination was. In BGP, we do that. For example, AT&T in this context might hear advertisements from LBL, UCB, and UCSF. It's not just turning around and advertising those prefixes to Verizon. Instead, it's aggregating them into a shorter prefix and advertising that shorter prefix. Okay? So for scalability, BGP may actually aggregate routes and destinations for prefixes. That's one big difference. Does that make sense? Any questions on that, or anyone want me to repeat it? Okay. The second, we've touched on this again already, you're not necessarily picking shortest paths or least cost paths. Right? So BGP, you're going to select the best route based on this general policy that we said every AS can implement. And that policy is not optimizing some well-agreed upon cost. So it's perfectly reasonable in BGP to have a topology like this, where node 2 is going to say, I'm going to reach 1 by going through 3. Node 2 prefers the path 231 over 21. That's totally fine in BGP. This should cause you concern. What's the immediate thing you think of when I tell you I can go 231 instead of 221? What's the thing we've been worrying about so much in distance vector? Loops, right? Least cost path, routing had this beautiful property where I'm decrementing in this cost at every step, and so I don't get into loops. If I can't rely on that anymore, I could have loops anywhere. Right? So how do we actually avoid loops? Any ideas? Very different approach from all the things that, split horizon, poison rivers. Forget all about all those techniques. So there's something completely different you could do to avoid loops. Yeah, keep track of what that path is. You should have this slight thought of, why didn't distance vector do that? What BGP does is, instead of doing distance vector routing, it does what we call path vector routing. Right? And so here, when you advertise, you also advertise the path, the entire AS level path to that destination. So for example, here when A advertises to B, it says I can reach this destination via the path A, because you're the only AS. When B forwards that on to C, it says I can reach the destination along the path BA. So when C turns around, data goes from C to B to A, but if, sorry, my slides here are all messed up. The key idea, let me recap it. The key idea is you advertise the entire path. So the distance vector, in distance vector routing, we sent the distance metric per destination. In path vector, we're going to send the entire AS path associated with the destination. Okay, so it's going to do what we did. And loop detection now is when C turns around and advertises to A, it's going to send an advertisement that looks like, I'm going to the destination along the path CBA. Right? So it's actually trivial for A to look at that advertisement and say, I'm on this path, this is a loop, and it throws that advertisement away. Right? So you're doing loop detection. Any questions on this? Great question. Aren't we revealing something about our policies when we do this? We are. But this is kind of the path of exposing your policies that's inevitable. What you are exposing is the path you've chosen. You're not exposing what paths you heard and which paths you rejected. So you're right that there is some leakage, but I would argue it's almost fundamental that you have to reveal this. Any other questions? All right. So just to recap, the key idea, advertise the entire path, different from distance vector. The benefits, loop avoidance is easy. There's another benefit that we don't really know how often this gets used, but it is certainly possible, is that you can look at the entire path and base your policies on the entire path, not just your next hop, or not just your cost. So you could say, oh, this path is going through some country you don't like along the way, and so I'm not going to pick it. That's actually something you can do with BGP. And the last difference between BGP and distance vector is what we call selective route advertisement. So in distance vector, the way we've been talking about it all along, we've been saying I receive an advertisement for a destination, I update my least cost, and I forward it on. You never had in distance vector a node that receives an advertisement to a destination and says, I don't like this destination, I'm not advertising it. That's not how the context we were operating in for intra-domain routing. But that's exactly what we're going to do with BGP. So in BGP, for policy reasons, an AS may choose not to advertise a destination. Right? So I can have a graph like this where B hears from A, and a route being advertised, and says, I'm not going to advertise it to C, because if you advertise it to C, you're going to be asked to carry traffic to that destination. And if B doesn't want to do it, they're just not going to advertise it. Do you see a problem with that then? Now that we're saying every AS can choose not to advertise certain destinations. Yeah? It just drops it. Yeah. Right. This should be, a serious cause for concern, because what this is telling us is reachability is not guaranteed with BGP. Even if the graph is connected, that means I have links and I can draw this connected graph. Reachability is determined by whether all the right ASs along the way chose to advertise a path or chose to advertise that prefix. This should sound concerning, like how is the internet working? We'll get to in a few slides about why, in practice, most of the time, unless we're talking about bugs or misconfiguration, why this is not, in fact, a problem. So just to recap the 4 differences, BGP can aggregate destinations and routes, which we didn't do in distance vector. Selection is not based on shortest path. You advertise the entire path, not just the least cost. So it's a path vector protocol. And you are selective about which prefixes you choose to advertise. Yeah? Right, so typically you lose some information when you aggregate, because what you would be telling Verizon is all of these prefixes routed through me, AT&T, and you kind of lose the subtle differences between the distance from AT&T to maybe LBL, UCB, and UCSF. You lose that. One could argue, that was the only path to those prefixes in any case. So the downside is not that good. Any other questions? Yeah. Right, so I think the question is, in the multi-homing example we had, where we had a link from LBL to Verizon, and we said Verizon has two entries in its forwarding table. One is for a /8 for A, and the other one would be a /16 for A.B. And so how would Verizon choose how to